Counting techniques. Combinatorics is the study of the number of ways a set of objects can be arranged, combined, or chosen, or the number of ways a succession of events can occur. Each result is called an outcome. An event is a subset of outcomes. When several events occur together, we have a compound event. The fundamental counting principle states that the total number of ways a compound event may occur is n1 times n2 times n3 times and so on up to ni, where n1 represents the number of ways the first event may occur, n2 represents the number of ways the second event may occur, and so on. First example, in how many ways can you create a pizza choosing a meat, a vegetable, and a type of cheese if you have 3 choices of meats, 4 choices for vegetables, and 2 cheese choices? According to our fundamental counting principle, this would be 3 for the meats, 4 for the vegetables, 2 for the cheeses, all multiplied together. 3 times 4 times 2 is 24 different pizzas. A permutation of a set of n objects is an ordered arrangement of the objects. The notation is a capital P with n, that's our total objects that we're choosing from, and the second value is how many we are choosing from those n. So if we're using up our whole set, it will be npn. And this is equal to n factorial, which is n times n minus 1 times n minus 2 all the way down to 1. If I'm arranging r of those n objects, then our formula is npr, which is n factorial divided by n minus r factorial. Now, on your TI calculators and most other calculators, there is a button for permutations. To find the button for permutations, we're going to look under Math and scroll across to Probability. And you'll see number 2 is NPR. Now, to enter this, to use this function, we first have to enter our value for n. So for example, if I want to calculate 10p2, I would enter it like this. 10, math, scroll over to probability, choose 2, and then enter the 2. And the answer is 90. We'll work some more with the example in just a minute. Example 2, in how many ways can 6 people be seated in a row? So we're using all of our set, so we have 6p6, which is 6 factorial, or 6 times 5 times 4 times 3 times 2 times 1, which is 720. Now we can also think about what's going on here. We have 6 chairs and 6 people to put in these chairs. So for the first chair, for chair 1, I'm going to pick one of those 6. So I have 6 different choices of people. No one's sitting down yet. So we put one person in chair 1 of those 6. Now this person's sitting down, so for the next chair we have only 5 people left to choose from to sit in that chair. Then the next chair, we have 2 people sitting down, that leaves 4 people to choose from, and so forth and so on. 3, then 2, then 1. So if I had, for example, maybe I had 6 chairs and I want to seat 3 people, in a row, notice that we're just going to be using these first 3 choices, 6 times 5 times 4. And that is equal to 6p3, which is n factorial divided by n minus r factorial. Example 3. In how many ways can 3 of the 6 symbols given here be arranged? Keyword for permutations is that it is an arrangement. So again here I have 6 total, so that's my n, and I'm arranging 3 of them, so that's my r. Let's do this one with the calculator. I'll enter 6, go to math, scroll over to probability, and scroll down to number 2 or select 2, hit 3 and enter, and our answer is 120. When we're allowed repeated values, if we're going to use the same thing more than once, the number of orderings taken r at a time with repetition will be n to the r. For example, suppose I want to take 4 letters from cougar, C-O-U-G-A-R. So I have 6 letters total. So that's my n. I'm taking 4 of those, so I'm making a tag using 4 letters. So I have 6 choices for the first letter. I'm able to repeat, so I haven't used up. I still have the same 6 choices for the second, the third, and the fourth. By the fundamental counting principle, we multiply all those together. Again, this is n to the r, and this comes out to be 1296. Now suppose that we want to work with an arrangement where we have letters that repeat or something that repeats. The number of permutations of n objects taken n at a time with r that are alike and s alike of a different one and t alike of another one is found by this formula. N factorial divided by the occurrences of repeats, and if I have more than 3 I go on, if I have less than 3 I don't write this many. So let's look at a word that has a lot of repeats and do a permutation for that. I want to know how many different arrangements I have for the word Mississippi. Now keep in mind, if I switch these 2 S's, it's still the same word. So we're going to take that into account by using the formula that we just spoke of. Now first of all, we have 11 letters in this word. So that's our n. Now we need to count up all of our repeats. Well, M doesn't repeat. There's only one of those. I occurs 4 times, S occurs 4 times, and P occurs twice in this word. Since there's no repeats for M, we're not going to worry about it. So our arrangements for Mississippi will be 11 factorial divided by all of our repeat factorials. 4 factorial, 4 factorial times 2 factorial. And that answer is 34,650. Now, to have the calculator work these factorials, that can also be found under math probability. So if I'm entering this on the calculator, I'm going to do 11, and then my factorial is found under math probability, and it's number 4, and then I'm going to divide that by, let's put this in parentheses, a 4 factorial times another 4 factorial times a 2 factorial. Now let's suppose that we're seating people around a table. This arrangement would be the same if everyone stood up and shifted over one seat. So we call those circular permutations. The number of circular permutations of n objects is n minus 1 factorial. So if I want to know in how many ways 12 people can be seated around a circular table, it is 12 minus 1 factorial, or rather 11 factorial, which is just over 39 million. Now all of these examples have dealt with, the recent examples have dealt with permutations, and in permutations we worry about order, arrangements. Suppose we don't care about the order or arrangement of our elements that we're working with. A combination gives a number of ways of picking our unordered outcomes from n possibilities. The number of combinations of a set of n objects taken r at a time is found by this formula: n factorial over r factorial times n minus r factorial. The notation is similar to the permutation formula. Sometimes you will see it like this in parentheses with an n over r. Combinations, again, order does not matter. So when trying to decide whether we need a permutation or a combination to work out our problem, we need to think about, does it matter if my list, my people, my values, my letters need to be in a particular order? Suppose we want to select a committee of 5 people and we have 12 to choose from. Well, in this committee, it's not going to matter who is sitting in a certain place or holding a certain office. That's not stated in this problem. So order does not matter. We're choosing from 12 people, and our committee will consist of 5. So we will do 12C5. Again, the other notation would look like this. No fraction bar here. This is n factorial divided by r factorial times n minus r factorial. And we can do this on the calculator. I want to do 12C5. So I enter 12, math, probability, and it's number 3. Our answer is 792.